Hello everyone. So this video is about solving and graphing linear inequalities. So it's a follow-up lesson to the equations. We use the same principles, we just have one extra step that we have to discuss. So by the end of this, you're going to be able to graph and solve one variable inequalities, otherwise known as equations with a different symbol in them. So first off, we have to discuss what the graphing means. So there are four basic types. So there's a x is greater than, x is less than, x is greater than or equal to, or x is less than or equal to. And I'm just going to put a generic number sign here. Now, this also can be written the same way . These are read the same exact way. The trick with this is you have to read from the variable. And if you remember back, they talk about the alligator eating the bigger number. Well, you have to read from the variable. So in this case, if the alligator's eating the x is greater than that other number, whatever number that is, even if it occurs on the right-hand side. While here, the alligator's eating the number, so x is less than the number. So you have to read it from the variable. That always helps you when the graphing comes in. Because whatever number there is, this just means, okay, these are going to be different types of circles. So in this case, I'm just going to put circles over any given tally mark, and you can put any number you want. Now, x being greater than the number means that it's going to go to the right. Bigger numbers go to the right. Now, x is greater than a number, let's say 5, means it can't be 5. It has to be bigger than 5. So it has to be like 5.1, 5.2, but it can't be 5. So that circle is open. In this case, x is less than, it points to the left. The only thing that changes, now x is greater than or equal to. So it could be a number like 5. So that means that the dot gets filled in, but the arrow goes in the same direction. Same thing with the less than or equal to, it goes in the left. So those are the basic things. But we use the same principles as solving equations, and then we just graph them on the number line. So in this case, x minus 8 is less than or equal to negative 6. I'm still going to draw my line. I'm still going to add 8 to both sides. So now x is less than or equal to 2. Well, now I have this number line. Well, I'm going to put 2 here. That means 1 and 0 are over here, and 3 and 4 are over there. But you don't really have to fill that in. We're just trying to get a sense of where this number is. So this is x is less than or equal to, so it's a closed circle over the 2, and it's pointing to the left, numbers that are lower than 2. In this case, I have variables on both sides. So again, I'm going to use that same rule that I told you before. I'm going to move the smaller number. Now, the smaller number, this is negative 2, this is negative 1. Negative 2 is smaller than negative 1. So what I'm going to do is I'm going to add 2 to both sides. Add 2a to both sides. These cancel out. I'm left with 4 is greater than 1a, or just a. So a is less than 4. So now I'm going to put 4. That means 3 is over here and 5 is over here. I'm going to put an open circle because it's not equal to, and a is less than, I'm going to the left. So that's the general way of solving an inequality. There are a few different rules here, especially when we get into multiplication and division. Now, 2x plus 4 is greater than 36, I can solve this the normal way by subtracting 4 on both sides and dividing by 2. X is going to be greater than 16. Now I can draw a number line. I'm going to put 16 here. That means 15 is here and 17 is here. It's going to be an open circle, and it's going to be pointing to the right because X is greater than. Now, example 2, same basic process, but there is a rule that we have to discuss. Now, I got to get rid of this 17 first because it's adding to the negative 3w. So I'm going to subtract 17 from both sides because 17 is positive. So when I move it over, I have to change the sign. I'm left with negative 3w. Remember to carry down the sign for the number is greater than or equal to 18. Now, here comes the rule. The next thing I do is I divide by negative 3. Whenever I divide by a negative, I now have to flip the inequality. It is not that I got a negative answer. It is that I divided by a negative number. Whenever you, and I'm going to expand this too, multiply or divide by a negative number, you must flip the inequality. That is the key to this. So the fact that we had to carry down the negative and then remember to flip the inequality changes the graph. And you're going to see this whenever I give you any practice problems, that now on a number line, I have negative 6. That means the number line is going to look like this. It's going to be a closed circle, but now W is less than. The arrow is going the other way. So you have to be careful with that. Now, there are practice problems on this. Please complete that. But on page 3, there is something called compound inequalities, which we're going to go through right now. Compound inequalities are basically two inequalities put together. So there's and there's or inequalities. And inequalities are called the union, where the arrows kind of overlap. Or inequalities are where they don't overlap. Okay? So if I look at this, you'll notice that negative 3 is less than or equal to 2x plus 5, which is less than or equal to 19. Now there's two different ways of doing this. I can look at it and I go, I can cover that up. I can solve that problem, right? I'll subtract 5 from both sides, then I would divide by 2, and I would get x is whatever. I could also cover this up and go, well, 2x plus 5 is less than or equal to 19. I would again subtract 5, divide by 2, and I would get my answer. The trick with compound inequalities, I can actually solve both of these at the same time. So, what I want you to do is look at the middle portion. That's where the x is going to be, in the middle portion. I'm going to draw two lines. Now it's like almost like I have two equal signs. First step, if I cover up this negative 3 over here, I would say, okay, 2x plus 5 is less than 19. Well, the first step I would do would be subtract 5. Well, I'm going to do the same thing, except for instead of just doing it on these two sides, now I'm going to do it on every side. Negative 3 minus 5 is negative 8. It's less than or equal to 2x, which is less than or equal to 14. Now, again, I cover up 1. I go 2x is less than or equal to 14. I'm going to divide by 2. And now I just add that dividing by 2 on the other side. So what happens is I get an inequality. Negative 4 is less than or equal to x, which is less than or equal to 7. So that means, if I read this, x is in between negative 4 and 7. Because it's in between, it's greater than negative 4 and less than 7. Do I have to flip the inequality because I have a negative 4 here? Well, going back to that previous rule, I only flip when I multiply or divide by a negative. I divided it by a positive, so I don't have to flip. So if I'm graphing this, I would actually have two circles. One at 7, x is going to be less than 7, and one at negative 4, and x is greater than negative 4. And where these graphs meet up is my graph. That's my union. Or statements are different. It's where they don't match up. And you'll see two different equations. 3y minus 2 is greater than 7, or 2y minus 1 is less than or equal to negative 9. That means I got to solve two different equations and then graph them on the same number line. So if I solve the 3y minus 2 is greater than 7 first, again I'm going to add 2, then divide by 3. So y is greater than 3. Now, 2y minus 1 is less than or equal to negative 9. I'm going to add 1 on both sides. 2y is less than or equal to negative 8. I divide by 2. Y is less than or equal to negative 4. Those are my two inequalities now that I have to graph. So, when I have my number line, my lowest number is negative 4. My highest number is 3. Well, y is greater than or equal to 3. Closed circle going to the right. Y is less than negative 4. Closed circle going to the left. You notice that they point away from each other. Oftentimes, you guys are going to see that with or statements. So, oftentimes, or statements point away from each other, meaning it's where they don't meet up. If they or statements point towards each other, they kind of like crisscross, and it's like all real numbers. And sometimes that's the trick question there. And statements are where they overlap. So if I have two graphs and I'm overlapping, it's like putting them together so it creates like barbells. If they don't overlap, like an or statement, then it's no real numbers. So those are kind of the special cases when you have an and or an or statement. But most of the time, and statements are going to point towards each other. They're going to be like barbells. Or statements are going to be like arrows. They're pointing away from each other. So these are the notes on this. Please complete the practice problems, then come in with any questions the next class. Thank you.